starting the recording right now because it's 6:01. Good evening, everyone. And Linda, if you can, and I know you threw the slide up there, so if it's not too much of a detour or disruptive, and please feel free to tell me if it is. Can we throw up a poll and see how people are doing?
Absolutely.
Okay, excellent. Now this is an anonymous poll, so you know, if you're telling us that your life is in the toilet, we won't know who you are. Linda probably will think of something less gross than saying your life is in the toilet, but.
No, that's a pretty good metaphor.
Okay, in the toilet, there we go. Okay, so please give us some feedback on this. I love seeing the great. Well, I love seeing the great if that's not you, Linda.
No, it is not.
I mean, Linda, I wish you good things. So, I mean, I hope your life is great. But okay, I'm kind of thinking that's maybe a good thing. I mean, if people are okay, that's not bad for where we are. So I think that's I'm okay with that. Now, if you are in the toilet, though, I have recommendations for you. I would say, hey, see if you can go to Linda's GSG sessions, or see if you can go to my office hours. And by the way, a handful of you have been showing up in my office hours, and that's fine. I'm trying to be helpful. I hope I am. And then also Cheryl Martin's math assistance area is open. Oh wow, over 70 hours a week, and so there's a good way to do that as well. Okay, so that's the fix. And also, I do meet with students outside of office hours as the need presents itself, and sometimes it does, and so I'm happy to do that, although we have to arrange a time. And again, tonight, we're always blessed to have Linda with us, but she has a meeting that happens, so she'll be leaving around 7, and I will just carry on without her, and so, but that will be good. But Linda, if you're up for working hard during this other time, I have plenty that I'll probably ask you to do. But if I ever ask you to do something that's too outrageous, feel free to say so. And
of course.
And I will step back. Okay, let's go to the next slide, please. Oh, I could have done that. I'm sorry. Okay, the first part of this is just me talking about some things, and then I'll give Linda an opportunity to say something that she does, and then students can always ask questions, but there's a time slot here when I will ask you for questions, and then we'll go ahead. Okay, so some things. I think I achieved a hurdle, or at least we reached a good point, I think, with the book. Some of you have been able to get the book, so that's good, and that is due in no small measure to Carly Oden. And I don't want to say she's the only person at Pearson that I trust, but she's done me some solids in the past, and she is a true professional. She actually knows what she's doing, very much so. And she's not reading from a script, she's listening, and then she just fixes things. So she really is a fixer, and I owe her a debt of thanks for that. But I think we're where we need to be. So anybody that wants to do the book dance, and the book dance is not necessary, but if you want to do the book dance, it can be done now. Okay, so that's kind of closing the book on the book saga, as far as I'm concerned for this. Now, by the way, if you are buying this book, you get a piece of the statistics book, and you get a piece of the physics book. And I really tried to pick this, the pieces that we're going to be using, so that is good. Now, we've had some LSAs, and I'll be rendering some grades, but these are going to be graded. The grades are going to be rendered gently here, and the LSAs should be, good for you. So that's good. I think, and I'm working from memory here, we had an LSA 1 that was on grade point average. We had an LSA 2 that was on actors and actresses, And we do have an LSA 3 right now that's dealing with normal distributions, and that's something that we covered last time, and so that's good. And I guess Eva has a comment there or a question. So Eva, what's on your mind? Eva, is your hand up? I'm going to say it another way. Yeah, is that Eva?
Yes. So I just like to clarify if LSA 2 was due last night.
Probably so, but I'm not giving you it. When is LSA 1 due? LSA 1 was due, I think, a while back, but still turn it in because I'm not exacting late penalties for you. And I don't know if Linda paid attention to that. I think LSA 2 was supposed to be due sometime, but I guess I'm going to, and I don't want to say don't worry about the due dates, because you should worry about due dates, because that's how we're trying to pace the course. And if you get yourself behind, that won't help you. Linda, do you have any idea when LSA 2 was due or is due?
I believe it was due last night.
Okay, but if you didn't get it done last night, turn it in anyway, and I'm not penalizing you for that, but you should do it because you see those are learning opportunities, okay? So Eva, I hope I answered your question. I'm going to lower your hand now. Okay. Now there will be more videos coming soon. For example, I posted videos dealing about straight line growth and exponential growth, which were good videos. And also I did something about scatter plots. And if I hadn't gotten rudely interrupted with a power outage, Linda, were you in the Learning Commons when the power outage happened?
I was in the Learning Commons for about 4 power outages.
Oh, okay. So yeah, well, actually I left after the first one. I got disgusted and went somewhere else. But it was one of those power outages. And by the way, I am old enough and experienced enough that I ought to know to save my work, but I was saving my work on a Learning Commons machine, which gets erased whenever it gets shut down. So I lost a whole bunch of work, and that's okay. I philosophically now think, if I have to do that over again, I'll probably do it better than I was doing it the first time, and that's normally true. But there are going to be more videos coming very soon, and I'm going to probably be posting them, I would almost think, tonight. Okay, so I'm showing you a lot of videos you're supposed to be watching, and this is probably one of those rare instances where my lecture tonight might even be a little bit ahead of the videos, or at least some of the videos. We'll see how far we get. But so there's more videos coming soon, so stay tuned and stay plugged in. And tonight we're going to be finishing up, or almost finishing up, chapter 3 in the statistics book, at least the area that I'm covering, and then we'll begin talking about chapter 4, which is regression analysis. And maybe that's all I really want to say. Linda, do you have anything you want to say to the students?
Not especially. We are still getting really awesome attendance at the guided study groups, which I'm really happy about. A few of you were asking when the missed GSG will be made up. So I was thinking, just for everyone's convenience and satisfaction, that we would do it right before the midterm and make that a 2-hour GSG, if that works for everyone. That way you guys have a little bit of extra time right before to cram if needed.
Okay. Now I'm going to make a comment, and please understand this in the context in which it's being made. Linda, that's extremely gracious of you and everything else. But I'm also going to say, Linda, and by the way, you're not going to be surprised about me saying this.
I already
really
know what you're going to say.
I want you to get paid, and that was a day off. So that wasn't, Linda missed the GSG. That was that the College of DePage said, we're not going to have things happening on that day. And so Linda's being very gracious doing that. And I would say to Linda that make sure you get paid for that somehow, because
I will be.
all right, excellent. So that's okay, as long as you're getting paid. But that wasn't a missed GSG. Linda didn't miss anything. That was a COD day off, and I don't understand all that. And actually, I'd rather have class than have a day off, which is probably a sad statement about my life. But anyway, that's enough of that. And Linda, by the way, has never called me awesome, and she just called you guys awesome. She said there was awesome attendance. So she just wasn't talking about a lot of you showing up. She was talking about those of you who come, have good attitudes, and you're awesome. So that's actually a genuine compliment. So anyway, so good for that. Okay. Okay. So Linda has a plan for that, and she's being gracious as always. Okay, so that's good. Now I'm going to throw it open for student Q&A, and I'm going to count to 10 Mississippi and see if anybody says anything. And if not, I don't know. We'll see how it goes. Here we go. I'm starting to count. Monica, what's up? I thought Monica's hand was up, but maybe it wasn't.
It definitely was. I did see it.
Okay, but maybe that question, I don't know. There she is again. Monica, speak up, please. And I'm not hearing you, Monica, so can you chat or check your mute button or something? Or you can write in chat and Linda can read that.
Her mute is not working.
Okay, so can you type your question into the chat box?
I imagine she's probably working on that right now.
Okay, that's good.
How many points is LSA 2?
Okay, I will speak to that question, but the answer is I don't know. But here's what's going to happen. Every LSA will be equally weighted, and I'm going to correct you on that. And by the way, I don't know how Linda feels, but I really don't like Blackboard too much, because Blackboard insists you put points on everything. And here's what's going to happen. Along the way, at the end of the term, I'm going to take all the LSAs, and I don't know how many we'll have, but it's possible we could have 15. And so we might have 15 LSAs, and I'm going to then add up all your points on the LSAs, and I'm going to divide by however many points there were, and that's an average. You guys know that. So that's an average, and that will be a percentage between 0 and 100. So you're going to get 100. So each LSA counts that. Now, the reason I said 1 is because I can't put something onto Blackboard without putting a point value. So I put 1, but it's not 1. It's whatever it is. And in fact, Linda, let's just play a little game here. And this is a numerical game. So Linda, suppose I had 15 LSAs over the term, and I counted each one to be 10 points. So that would mean, Linda, 15 LSAs, each one 10 points. How many are possible, Linda?
Well, that would be 150 points.
Okay, and suppose student Susie, I don't think we have a student Susie, so this is, it is a hypothetical Susie, but Susie earned 100 points on those 150, she earned 100 out of 150 possible, and each one was equally weighted. So it was 100 out of that, and so 100 divided by, and I'm making Linda round things off here, but 100 divided by 150 would be what, Linda?
About 67%.
That's right, and by the way, that's 66 2/3%, but Linda's right, I would give you that, 1/3%. So that hypothetical Susie would earn that. The only reason I throw 1 point down there is because, you see, I don't even know exactly how many LSAs I'm going to have and stuff like that. Now, I do have a good idea of what we're doing in this course, but I'm sort of making up the LSAs as we go, and I never do the same course exactly the same way twice, because that would be boring, and actually I'm still growing as an instructor. I try to do things better each time I do them. So even though it says 1, totally ignore that, what it says. You should do the LSAs because they're learning opportunities, and this is an opportunity for it to be perhaps your best score of all the 3. I hope that was a good answer. Linda, anything you think you should add to that?
Not especially. If you guys do want to go over how much the LSAs are worth and how it's going to affect your grade, then you guys can definitely come talk to me as well about that.
Okay, Eva has a hand up. Eva, is your mic working?
Hello?
Yes.
Well, do you happen to have like a schedule on how often we'll be getting an LSA for us to like?
And by the way, this is gonna sound rude, but no, I can't tell you. I'm going to say more or less once a week, but it's kind of when I get around to it, and I'm not trying to be rude with that, but I'm juggling, a bunch of things, and I'm not the world's greatest juggler, and so, I do things when I get around to it. I will never deliberately be cruel about saying, oh, there's one out there, and when the and by the way, if I'm ever rude or unreasonable in what I say, Linda will call me on it, and she says, don't you think we ought to give the students a little more time on that? And so that will be fine. Somebody, and it doesn't matter who asked the question, but they said, when is the test going to be? And just because people want there to be a test, maybe people don't want there to be a test, but there is a test. I've always said it's more or less on midterm. The first day that you will be able to take the test will be October the 12th. And Linda, we should write that down somewhere, just because I just made a declaration. Now, the reason it's going to be October the 12th is that October the 12th is, I'm hearing 7 doing some work, I think, back there. That's good. No, and Linda's dog is named 7 and is a cute young dog. But anyway, October the 12th, and Linda, you might have seen the notice of that, but that's when we're having the in-service day, and that's a day off for the students. And so I'm saying, hey, that would be a good day to throw the test in there. And so I'll throw the test in there beginning that day. It doesn't have to be done that day. There will be a period of time to do it. And you guys should let me know if you have accommodation issues, like if somebody lives in, actually, I do have a student who is in Saudi Arabia right now. And so if you live in Saudi Arabia, you're not going to be able to come to the testing center and do it. So alternative arrangements, but you should be talking to me about that individually, not in a group setting here, about such accommodations. So Linda, I sort of decreed October the 12th, which is the in-service day. That's going to be the first day. And I don't know, I may say October the 12th through, I'm not going to tell you the last day because I'm not sure when it will be. Okay, and Eva had another, or actually somebody had another, I think it was Eva again. Go ahead.
No, I need to click it, sorry.
Hello?
Hi, yes, it was an accident. I didn't mean to click it, sorry.
Oh, that's, I mean, don't worry. I mean, this is, actually, I am teaching several courses face-to-face, and I'm relishing it. It is so much nicer to be there, even though I am masked. It is good. Okay, I'm counting to 10 again. Jasmine.
Can you hear me?
Yes, I can.
For the LSA2, I turned in the Excel sheets where I organized like the actresses by age, and then it didn't let me turn in my actual work, like the histogram and stuff.
Well, here's what, and I'm going to say what you should have done. Now, don't worry about this, okay? But here's what, and this is not just for Jasmine, this is for everybody. The way Excel works is there is one slot, and I'm going to be doing good if I have a slot for LSA2, which I did, okay? So there was a slot for LSA2, but you only get to submit one PDF to that. So what you should have done, Jasmine, and by the way, I'm not beating you up, you know, so please understand that, and I'm not being mean, but what you and everybody else should do is take all your work, the histograms and the essay question and the Excel spreadsheet and box plots and so on and so forth, and cut and paste those onto a single Word document, which you turn into a PDF, and then use something like Microsoft Office Lens or some other program of your choice, and make it into a single PDF, one PDF that you upload at one time. Because the way Blackboard works is you do one thing, and I'm doing good if I put LSA2 PDF slot, and so I'm not going to be putting LSA2 PDF for the histogram and, you know, all those different. So so what you should do, Jasmine, and I'm not telling you don't worry about it, okay? So it's not to have anxiety, but everybody crunch all your stuff together as a single PDF and upload it. And Linda, is that clear, or should you say more about that?
I think that's pretty clear. If you guys do need help with this, then I can show you how to copy and paste things and put it into a Word document as well.
Okay, so that's looking forward. Okay, I always restart the count whenever I answer a question, so I'm starting my count again. All right, excellent. That's good. I'm advancing the slide, and we're going to begin doing something. Now we're going to be talking about something, and Linda, I am going to probably be looking for you and Seven to do some work on this. We're going to talk about measures of central tendency and dispersion from grouped data. And by the way, some of you might be thinking, well, what the heck is grouped data to start with? Okay, and so, and here we go. Okay, and so this is what grouped data is. In fact, I'm going to go ahead a little bit and show you some grouped data. Here is some grouped data, and these are birth weights, okay? And so what we have is the following frequency distribution represents the birth weights of all babies born in the United States in 2017. And the source of this is, and by the way, the world does do data collection, and this is the National Vital Statistics Report for that year. And this talks about how much the babies weighed. And so you had a whole bunch of babies that were born. And so you can see 25,446 of them weighed between 0 and 999 grams. And by the way, I'm a little bit of a purist. They probably should say the mass of the baby, not the weight. And we'll talk about that later. But anyway, it's the mass of the baby. So they throw the baby on a scale and figure out how much the baby, what is the mass of the baby. And there were 4,241 babies that were between 5,000 and 5,999. Now, Linda, would you be willing to describe why this representation of data that was in the that was in this National Vital Statistics Report is different from other data that the students maybe run into in this class, like for example my test 1 and test 2 scores and things like that?
So normally with data, then you get the actual data points. You can see each individual weight, in this case, for each baby. Now in this case, then they're not giving you the weight of each individual baby. They're just telling you which range the babies fall into and how many fall into each range that you're given. So we don't have the actual data points. We just have groups and how many are in each group. Basically the same thing that you get from looking at a histogram.
Okay, that's an excellent answer. And by the way, Linda and I don't rehearse this at all. She's just smart and gives good answers, so that is good. And that's a great answer. So, and by the way, she actually used the word group, and so that's why this is called grouped data. Okay, so we get these things, and we're going to do a problem with this later, but we have some formulas. And Linda, when we get to this problem, I'm going to ask you to cut and paste this and throw it into Excel and do some things. At least that's my plan. Okay. All right. So now I'm going back though, and I need to go backwards then. Okay. So you see, now we're talking about group data. And I think actually maybe you can't see my cursor, can you? But I'm going to grab my hand. And Linda, can you see my hand waving about?
No, I cannot.
Maybe I need to get the pencil and try to wave that about. Maybe I can't do this at all. Okay. I really thought that hand thing worked, but maybe it doesn't.
Yeah, they changed some of the controls on Collaborate. It's all weird
All right,
now.
so I'm kind of giving up. This is torn from the book. This is the way the book reads, actually. But then we'll come to, all right, so what we're going to be talking about now is how do you approximate the mean? Because you see, you don't really have all the data points, so you can't use the formula we had before. And so what we have is, and 7-1 is volunteering to answer, but we'll just move on with that. Okay. So we then have to talk about a thing called a class midpoint, and that's in the middle of this page, and it's called a definition. So we're going to talk about a class midpoint, and you have to know what this is in order to do what Linda's going to do later in Excel. And I'm just reading the definition, and it says a class midpoint is the sum of consecutive lower class limits divided by 2. Now, this is the way Michael Sullivan does it. Other books do it differently. I don't care. We're doing it the way Michael Sullivan says. And so that is the class midpoint. And that is going to be the representation of that class. Okay, because you see, you have a whole bunch of things. Like you had a whole bunch of babies that were between 0 and 999 grams in mass. But all of those babies could have been 500 grams in mass, or they could have been totally spread out. So you need to come up with a representative value for the class midpoint. This is the definition. This is what you're going to do. So it's the sum of the consecutive lower class limits divided by 2. Now that actually means the average of the 2 lower class limits. And Linda's going to show you how to calculate that, but that is the representative value. And then we have equations. And by the way, we haven't talked much about this, but when you have your midterm, and I do this to reduce anxiety for the students, there is a piece of the test that's going to be called grace notes. And it's going to have a whole bunch of formulas on it. And so the whole bunch of formulas are going to have things that are like here. And so you see what you have here are the definition of the approximate mean of a variable from a frequency distribution, which is, this grouped data thing. So for the population mean, mu, what you're going to be doing is you're going to be adding up xi, where xi is the class midpoint. And by the way, it says that somewhere. Underneath there it says xi is the class midpoint. You multiply that by fi, which is the frequency of the ith class, and you're dividing by, you add up all the frequencies, and that's how you get the mean. And if this was a sample mean, you would do the same thing, but you would call it x bar, and you would add it up. Now these are formulas. You'll have access to the formulas, but you will have to know how to do this in Excel, and Linda's going to remind you how to do this in Excel very soon. Okay. And by the way, I don't think I'm showing you a decisions through data video that does this. So this is what you get, but Linda and I are recording this. I hit the record button, so this is being recorded, and this will be posted so you can look at it some more and, all of that. Okay, so you can find the approximate mean. You can also find the weighted mean. And the weighted mean means that there are different weights associated with this. For example, now this is not true in my class, but some of my mates in the math department say, oh, attendance counts for 5% of your grade. And we will have 2 tests, and each test will be 10% of your grade. And so that means that different things are weighted. And then that adds up to 5%, and 2 10% adds up to 25%. Then they're going to say, and the final is going to be 75% of your grade. Now that's an even higher stakes test than what you guys have, because you are a third, a third, a third. But still, and that's because I don't want to work hard with the calculation. But a weighted mean is you have weights associated with each score. And so that is X bar here in the formula. That's the weighted average is going to be, you add up the weights times the score that you get, and you divide by the summation of the weights. And that is called a weighted average. Linda, I'm going to ask you, the students actually have already done a weighted average problem. Can you remind them of what weighted average LSA they did that was a weighted average already?
So the first LSA actually is a weighted average because the different credits that you use when you compute the GPA give the different grades offset weights. So not everything is going to be weighted the same when things are worth different amounts of credit hours.
Okay, so that's an excellent answer. So you've already done a little bit of this, but it could be, something different. And I think we're going to do a weighted average right here. Now, I think I'm going to skip number 9, because number 9 is a grade point average, and you know how to do that. But I wouldn't be surprised if I ask a grade point average. But Linda, we're going to do number 10. And Linda, I'm going to ask you to do number 10 in Excel for the students in just a bit. Okay, but I'm going to read it first. Now, this is the same Marissa that was the star of problem number 9 here. But anyway, here we go. So in Marissa's calculus course, attendance counts for 5% of the grade. Quizzes count for 10% of the grade, and exams count for 60% of the grade, and the final exam counts for 25% of the grade. Now, Marissa had 100% average for attendance. That means she was there every time. She got 93% on her quizzes, 86% on exams, and 85% on the final exam. Now, the final exam counted a lot more than some of these things, and the exams counted quite a bit too. And so what really happens is, she got 100%, so you say, oh, she showed up every day, she got an A in the course. Well, maybe not. We'll see how it worked. Okay, so Linda, do you understand what I'm asking you to do?
I sure do. I was just setting it up.
Okay, so Linda's way ahead of us, as she always is. So Linda, I'm just going to turn this over to you, and here we go.
Okay. So for the attendance, then I'm putting down 5%. For quizzes, that's 10%. Exams are 60, and the final is 25. Now the grades, then we have 100% for attendance. We have, let's see, 93 for quizzes, then 86 for exams, and 85 on the final. Everyone with me so far? Okay, I'll take that as a good sign. So first thing I'm going to do, just like with calculating the GPA, then I'm going to do equals and multiply the percent by the grade. I can drag that down so it computes it for each one. I can take the sum of all those. And then I need to take the sum of all my percentages, which should be 100. Since the percentages are basically the same as the credit hours in this case, it dictates how much each of these categories is worth. So I do get 100. So then I can divide these numbers just like how we did with the GPA, and that'll give me the grade in the class. So she would end up with an 87.15%.
Linda, I'm going to ask you a different question that's not here, okay? But and maybe you may want to figure out a way to paraphrase my question. Suppose Linda was going into the final exam, and so everything else was done, and you had exactly the scores and things that you had. But what would Linda, or not Linda, what would Marissa have had to get on the final, or could she have gotten an A in the course? And let's just say the A is a 90. And Linda, do you understand the question that I'm asking?
I do. So your goal here then is to get this number to be 9,000. That way when we divide it by the 100, you end up with a 90%. So if that's what we're trying to do, basically you're taking the final grade, which in this case I'm going to put right there. So this is the 90% that I want to end up with. From there, I'm going to put it in terms of the amount of points that we need by multiplying it by the total percentages. So this tells me how many points I need over here. I know all the points that I've gotten so far by adding up all of these. So that's going to be my 500 plus 930 plus 5160. Now, when I add those two together, my end result minus whatever points I've already accumulated, this is going to tell me how many points I still need. Now, if that's worth a 25% on the exam, then I can divide that by 25. So I would need a 96.4% on the final exam to get an A in the class.
Questions of Linda, because I got to tell you, that's another kind of question that I've asked in the past, dealing with weighted averages. So we're pausing for questions here.
It is a little bit easier to see if you actually write out the equation as well, because then you can actually work through the algebra instead of trying to follow what I'm doing, which is just kind of manipulating cells.
Someone asked, and I'm paraphrasing. Someone asked in the chat, could you just talk through it again, please?
Yeah, so I think I'm actually going to write out this equation that we're looking at. That way we can just sort of go from there. So if I'm trying to get that 90% from before, then I'm doing 5 times 100. Yeah, 5 times 100 plus 10 times 93 plus 60 times 86 plus 25 times something, which I'll call X, because we don't know what grade I need on the final to get the A. And this is all going to be divided by 100 to equal 90. Because that's Linda, what I would need to get an A in the class.
This is algebra, isn't it, Linda?
It sure is.
Okay, there you go.
It's just solving for the missing piece that we have. So when I multiply both sides by that 100, that's going to give me the 9,000 over here. And then if we were to simplify these three pieces up top, we would end up with that 6,590 from before. So from here, I'm literally just continuing with the algebra. So I can subtract that 6,590 from both sides. And when I do that, then I end up with that 2,410 that we got earlier, which I then divide by the 25 to get the 96.4.
Okay, I think that was a good job. Someone asked, do we have to do this on LSA 3? Now, I'm going to answer that in two ways. Will you have to do something like this? Quite possibly on the high stakes assessment. LSA 3, as I recall anyway, dealt with normal distributions and a car servicing place called Speedy Lube or something. So you're not doing this on LSA 3, but actually more likely you're doing this on, or this or something like it, on the midterm, the high stakes assessment. So anyway, okay, anything else for Linda, or we do move on to something else? Okay, thank you, Linda. We're going to move on to something else. So let's go back to the PowerPoint show, please.
You got it.
Okay, so that's enough of that one. But now we move on. And you see back here previously, I'm controlling the slides now, but here we talked about approximating the mean of grouped data. So we had a formula for that. We also have a formula, we talked about weighted mean there, but we also have formulas for the population standard deviation and the sample standard deviation that are given here. And again, this is grouped data. And here's an algebraically equivalent formula. Now, Linda, here's what I'm going to be asking you to do for us. And I am watching the time, Linda. I think we can pull this off. If not, I can jump in and finish it. But I think we can pull this off before you have to go to your meeting. And so this is going to be, so we're going to need some of those formulas that will be in your grace notes. We're going to need to know how to do them. And so now we're going to go back to the baby problem here. And what we're going to do with the baby problem is we're going to use that data, and Linda's going to use this grouped data to approximate the mean and the standard deviation birth rates, okay? And Linda, don't worry about problem B or part B to this, but let's also look at part C, and we'll see how that matches up with the empirical rule, which is a good thing. So Linda, am I being clear what I'm asking you to do?
Yeah, just A and C. Sounds good.
Okay. All right, so please give it a go, and you guys pay attention, because I could ask you to do this on maybe an LSA, or maybe someday on a high stakes assessment. Okay.
All right, so the first thing I need to do is find the group midpoint for each of these. Now remember, the way that we found that was by taking the average of the lower limits of the group that we're currently looking at, so the bottom group, and then the group above it. So for the first one, I'm looking at the 0 and the 1,000. And when I add those together, I still get 1,000. And when I divide that by 2, then my first group midpoint is going to be 500. Is everyone okay with that?
I'm seeing some yeses. That's good.
Great, love it. So next I'm looking at the 1,000 and the 2,000, which when I add those together, I get 3,000. So half of that is going to get me to 1,500. And you can see as you do these, it's going to keep increasing by 1,000 each time. So for my next group, that's going to be 2,500, and 3,500, 4,500, and lastly 5,500. And then I'm going to fill in the actual numbers. You guys let me know if you're good with the group midpoints, those. Everyone good?
And you
I'll
see,
take that as a yes.
This is a hard problem. I mean, this would be a hard problem if you didn't have Excel, because there's just so many numbers here. But go ahead, Linda.
All right. So if I'm finding my approximate mean for this group data, then I'm doing this exactly like I would for a GPA problem. So my numeric grade is the same thing as the group midpoint. So for here, then I'm doing the group midpoint times the number of people in that group, and then I can drag that down. Next, I can get the sum of those. And I also need the sum of the total number of babies that we're working with here. Everyone good so far?
Linda, you must be doing a brilliant job of explaining this. I'm sure you are, actually. This is good.
So the next, what we're going to do to get the mean is divide those two numbers just like we would with a GPA. So this is my mean, and I have now labeled that accordingly. Okay, so to get the standard deviation, I'm going to be following the formula right here. Now, is this a population of all the babies or a sample of babies?
Well, Linda, I'm going to suggest that this is all the babies that were reported. But I bet you there were some babies that were not reported for all kinds of reasons, okay? And so
I'd
let's
agree.
just
I'd say this is a sample.
Yeah.
All right. So we're going with the sample standard deviation formula, which means I'm going to need to subtract 1 in that denominator before I take the square root. So first thing I need to do, just starting at the very, very inside, I'm going to take those group midpoints and subtract the mean that we just found from them. So I'm going to do that in column F over here, and this is going to be midpoint minus mean. So I'm taking each of my group midpoints and I'm subtracting, and this is in cell C10, so I need to do my absolute cell references, which are just those dollar signs surrounding the C. So I hit enter, and I'm going to drag that down so it gets all of those group midpoints. Okay? Now my next step is to square that. So I'm just going to call that a little caret squared. And do equals, take my cell from column F and square it. So I drag that down. I've done that for each of my midpoints. Now, next thing in my formula is I need to multiply those by their respective frequencies. So I'm going to call this star F for times the frequency. Take that previous cell that I was just working with and now multiply that by the number for each of those groups. So I can drag that down. And now I've done everything in the numerator except for adding those up. So that's going to be the next thing I'm going to do. So take the sum of all of those numbers that we just got. Any questions so far?
I have a question, Linda, and do you think we ought to talk now about, now I am going to later in the course show the students the powers of 10 video, and when you're taking square roots, that probably will come back to just a regular number, I don't know, but should we say anything about that E plus 12 now or not? I turned that into a question.
Probably.
You see how I did that?
Yeah, so that E actually means it's kind of scientific notation, but what I can actually do is just increase that quite a bit and make that into a number. So all that means is it is a very, very big number with a lot of decimal places. So they're just writing it so it's times 10 to some power. That's what that E stands for. So every time you see the E, then that means times 10, and then the number following it is the exponent attached to the 10.
And we're going to be doing that big time in the second half of this course.
Yeah. So we've got our numerator. The next thing we need is that denominator. And since we are working with a sample, then we need to subtract 1 from the sum of all the frequencies. Now, I actually already got that number when we were finding the mean. So I can do equals, take that, and subtract 1. And then lastly, well, almost lastly, I can divide these two numbers. So my numerator divided by my denominator. And then to get the standard deviation instead of the variance, then I need to take the square root. Now remember, you could either do equals SQRT and open a parenthesis, take that number and take the square root that way. Or what you can do is do equals, take the previous number and raise it to the 0.5 power. Those are both equivalent ways to take the square root.
Hey, Linda, you're cutting out a bit, and one of the students actually used that. And so I don't know, sometime, I don't know what to do, and we'll just see. Maybe that will just go away, or maybe, I don't know. I'm just letting you know.
Okay. Is everyone with me on how I at least got to the 423,000 and change?
Tell you what, I'm going to say something, and Linda, you point. I'm guessing that I am maybe not cutting out. I hope not. So you can't hear Linda, but you can hear me, I hope. So I'm just going to talk, and Linda will point maybe. Okay, so what Linda did was she went down here and she actually divided. So she was using that formula, and she divided that 163 big O number, and she divided that by the denominator, which was that -1. And then she took the square root of that, and she's going to show you the formula for the square root. She'll click on that cell, and if you look up there in that, you'll see there's the square root of, and she clicked on H11, which is that cell. And then she also told you that in I, column I, that's the same thing as raising it to an exponent of 0.5, and that's what math guys and gals like to do, just because it's, I don't know, it's elegant or something, I guess. Okay, so So that's what she was saying. And now I'm going to just keep talking, but Linda, I'm going to ask you to do a few things. It asks us also between what two numbers are 68% of the data, and that was from the empirical rule. Now what we're going to do for the empirical rule is, the empirical rule says that if you take the mean minus 2 times the standard deviation, and the mean plus 2 standard deviations, that will be the two numbers where 68% of the data should be, okay? Because that's what the empirical rule says. And so between so it's between, in this case, it is x bar minus 2 times s, and the other number is going to be x bar plus 2 times s. So Linda has to figure out that, and she's doing mean plus 1 standard deviation, then she's probably doing mean
Isn't
plus
it
2
just
standard.
between 1 times the standard deviation?
You're right, Linda, I wasn't paying any attention.
Since it's 68%?
It's 68, not 95. Thank you, Linda. You are, and by the way, Linda, you sound clear to me now, so you fixed whatever was going on. So I'm giving the ball back to you, Linda.
All right. So I'm taking the mean and adding the standard deviation, and then I'm going to take the mean and subtract the standard deviation. So it would be between these two values.
Okay. All right, so I think we've done some. I think we've done some good work here, and I think that's good. Okay, so and Linda, I am watching the time, and it is 6:57, and I know to get to your other class that you're doing, you need to leave around 7. And so, and you probably want to, I don't know if you have 7 get into a crate, so your ball board doesn't get chewed up or stuff while you're gone. I don't know what you do, but you might have to do that. So I think I'm going to say thank you for your work tonight, and we will be talking to you soon.
All right, sounds good. Have fun.
Okay. All right, so we have a bit more to do, but that's good. So Linda did that, and we talked about that. Now here is a problem. That is not an LSA yet, but it could be. And in fact, maybe I'll make this LSA 4. Now don't write that down yet, because I don't know I'm going to make this, but this might be LSA 4. Let's just talk about what it is. Okay, so this is a different problem. It says the data represent, and again, since data is plural, you say data represent the male and female population by age of the United States. And again, this is a sample because there are some people who don't want to be counted. And if you look, this is the US Census. Now, census really was supposed to be counting every last soul. That's the intent. But there are people who hide and so on and so forth. So, and I can understand that, and we won't go into that, but yeah. So this is a sample, but it shows you how many, and these are big old numbers. These are millions, and you got males, and you got females, and so on and so forth. So anyway, you've got that, okay. And then, by the way, down here, and I know you can't see me point, but down here there is a bigger than or equal to 80, and there's say use 85 for the midpoint of things bigger than that. Okay, so you got all these numbers, but then here is what the question is asking. It is asking approximate the population mean and population standard. It said population mean. Whoa. So they're pretending that's all the males in the US. So they're saying population mean and population standard deviation for males. Then you do the same thing for females. And then they ask which gender has the higher mean age and which gender has more dispersion. That means bigger spread, a bigger standard deviation. So you see, this could be a problem where you could actually practice doing that. And I may someday force you to do that by assigning this as an LSA off into the future. But it's not an LSA now, and we're not going to be doing this, this right now. Okay. All right. So that pretty much does this part of it. And now we're going to move into a slightly different topic. And the slightly different topic is called scatter plots. Now, I ask you to watch videos, and one of the videos dealt with linear growth, another one dealt with exponential growth, and another one dealt with scatter plots. Okay. And so what we have is then we're going to be talking about scatter plots here, but we need to talk about a little things. And what happens is this definition that you hear, that is shown here, is in fact what we will see, what you'll see in the video. It's exactly the same definition, but we talk about now we're talking about two variables. So before we were just talking about one variable, like what was the mass of the babies, or what was the weight in pounds of the bears, or how tall was a bear, or something. But now we're talking about different variables. We're talking about two variables, and two variables back when you studied your math was x and y. So what happens when you got x and y then, one of the variables is called the response variable, and the other variable is called the explanatory or predictable variable. Now I'm going to write on this chart, or at least I'm going to try to. So I'm going to draw, and I'm going to, we'll see if this works. Okay, so the response variable, and it didn't take the pencil again, so I want to do the drawing. And maybe I have to pick a color. I'm picking black for my drawing. Now, I think I've got this now. So this is the response variable, and the response variable is the y, because you all remember that y is equal to f of x. So that says that y depends on x. So the response variable is y, okay? And the predictor variable is then, we'll go over here and do this. This is going to be x. Because you see, back in the day when you're graphing things, you'd pick x and you'd get y, okay? And now we're going to talk about what a scatter plot is. And again, I ask you to watch a video. If you haven't watched it yet, please go and watch it, because these videos actually are very well done. But here's what the definition of a scatter plot is. And we're going to do some scatter plots with Excel. So a scatter plot is a graph that shows the relationship between two quantitative variables. Now, quantitative means that these are numbers. So we have numbers for all these. So a scatter plot is a graph that shows the relationship between two quantitative variables, and they're measured on the same individual. Now here, in the thing that we're going to be talking about here soon, is we're talking about bears, and these are bears that are critters, okay? These are not, they're not Chicago bears, okay? Now we could do the same thing with the Chicago Bears, except that wasn't the database that I gave you. So these are the bears that we have. Okay, so we have quantitative variables on the same individual. In this case, it will be the same individual, bear. And each individual in the data set is represented by a point in the scatter diagram. The explanatory variable is plotted on the horizontal axis. And by the way, that's what you always did, wasn't it? Because you put x there and you put y up here. So this is horizontal, that is vertical. And the vertical variable is plotted on the vertical axis. Okay, now we're going to go and we're going to look and we're going to do a scatter plot. And we're going to do a scatter plot of the chest girth versus the weight of the bears, okay? So what's going to happen in this case? Now, sometimes it is very clear what is the response variable, and other times it is less clear. But I'm going to say that the bigger the chest girth, I'm going to take that to be x, and the weight of the bear is going to be the y. Okay. All right, so that's what we're going to do. Now I've got to go and get the data for the bears, and if I ever ask you to do a scatter plot, which I really might, you know, you have to go and get that. Okay, so I'm going to leave here now. I'm going to go find my bears database, and I'm going to have to go to Blackboard and get the bears database. So what I'm doing then is I'm going to, oh, damn it. Is this Linda sharing the screen? I could be in trouble if I can't. I'm not in big trouble, but I really should have had her stop sharing the screen. I'm going to mess around for a while. Bear with me. It'll be fine. Okay, so I'm going to go to this thing, and I'm going to share the application screen with you. It's going to be this screen, and I'm going to share it with you. And now this said, okay, that's good. Okay, so I'm going to, I'm sharing my screen. So now I'm going to go down and I'm going to go to Blackboard. So I'm getting a new window. And I'm going to go to Blackboard. Okay, and it's going, and so you should be looking at Blackboard. And I'm going to go, I hope I put bears in here. I think I did. So I'm opening this up and I'm looking in your syllabus tab. I'm looking for bear, oops, that's announcements. I want to go to your syllabus tab and I'm looking for bears. Come on, bear, there it is, bears. And I hope that is bears, not Chicago Bears. We'll see what we get. It's loading, it will load soon. Okay, I will open the file. All right, I opened the file. It's trying to open Excel. And it's struggling. Somebody who can talk, can you still hear me?
Yeah, we can hear
I
you.
still hear you.
Yes.
Okay. All right, and by the way, you are not hearing me swear because I'm swearing inside my head. But this makes me mad that this isn't working better than it is. There's bears, good, okay, that is great. So now you can still see the bears, and where did they go? Here they are, they're the bears, and it is this one, and it opened it several times. So I'm going to enable editing because I'm doing something with this file. And here's the bears. Now I'm going to the top of this bears thing because you see what what I have here is I have bears and I have their chest girth and I have their weight. So these are the two variables that I'm going to do, and I am going to enable editing of this file. Okay, so I'm opening it as a read-only file. And then I have to save it as something. So I will save it as bears again. This is nonsense that you have to do with things. So I'm going to just save it that way. Okay, so now I can do things with this. So now what I'm going to do is I'm going to do a scatter plot. And so I'm highlighting these because I want to know what happens with the chest girth versus the weight of the bears. And I'm going to go up here and I'm going to insert a chart. So I hit insert. I'm going to go over here to the charts and I'm going to be pressing this button. And this is going to be where you will find your, what do I want to call it? Scatter plot, okay? So I'm going to do this and I get that. And there I have it. So you see, now I've built a scatter plot where each of those 50-something bears is shown here with a data point. So here's a bear, and I think actually if I go to that bear and if I click on that, that will tell me about that bear. Well, let's talk about this bear up here. Okay, so that bear is bear number 54, and that bear weighs 514 pounds. So this is a scatter plot, okay? And that's all you need to do. And by the way, Linda said she'd show you how to do this, but I'm showing you how to do this. I can copy this, and I am doing a Controlled C. And so I'm copying that chart. Actually, I'm going to do it another way. I'm going to do it here. I'm just going to, actually, maybe I can't do it that way. Does this say, yes, copy. So I'm copying that, and then I'm going just to I'm going to open a Word doc. And so if I had a Word doc, what I could just do, and I'll skip a couple lines, but then I'll say Controlled V, or I could just say paste. And what it's going to do is it's going to paste that chart here. There it is, okay? And I could make that chart different sizes and everything else. And so you see, it's really nice. So this is what you can do to upload your PDF. So that is a scatter plot, and we did that. Now we have a little bit of time left, not a lot, but now I'm still sharing my screen with you. So I'm going back to the PowerPoint show, and I'm going to go here, and I'm going to change this into again, it's a PowerPoint show. So that's what a scatter diagram is, and I showed you how to build one of those in Excel. Now we're going to go to the next one, and you see what we can have is, we can have a graph that looks like this, where when the explanatory variable goes up, the response variable goes up. Now back in the day when you studied your maths, you called this a positive slope. And so that is a positive slope. And we'll say that these things have a positive correlation. There are other things that you will see in the video. I think they talk about making cakes. The more cakes you make, the faster you'll be making cakes. And so there, it's possible to have variables that are negatively correlated. It's possible for there to be no relation at all with the data. And sometimes you will have things that are called non-linear data. Like here, this is what you called a parabola in your math, and this is a different kind of curve. That might be a cubic back in your math kind of thing. So you see, we'll talk about positive correlations and things like this. This is where we're going. And now I'm going to go to the very last thing, and this is looking ahead to the videos I'm going to have you do. Okay, we will determine a measure, and we're going to call it R, and that's what they'll call it in the videos I'm going to have you watch, called the linear correlation coefficient, and this will determine how close to a linear relationship the two variables are. The SIGN, the sign of R, determines whether it is a positive slope or a negative slope, or we'll say negative correlation or positive correlation, and the strength of the correlation is determined by how close to the absolute value of 1 R is. And one of the things I'm also going to do is point you at a video that is entitled "Correlation does not imply causation." So you're going to have several videos that you're going to watch, and this is where we're going. Now I do watch the time. I always watch the time for you, and we're at the end of tonight. So I'm going to close with I do have office hours later tonight. I got to go get some food before that, I think, because I'm getting kind of hungry. So anyway, the thing that I'm saying is time is precious. Each day must count. Do the math. It will make you strong. And I think I need to stop sharing. And I think I need to
go back and stop the recording somehow. Not sure how to do that, so maybe I'll just log off. Okay, take care, guys.